Hi, this is my third part of the video. Here I'm going to discuss about supervised classification algorithm. Um, so I have chosen the supervised classification algorithm as logistic regression. So moving on to the slide 10. So the data set for the logistic regression we have chosen is adult salary. So here the goal is to predict individual salary is less than or equal to 50K or greater than or equal to 50K, which is a binary classification. So the data set adult salary has been pre-processed. Initially, first we did label encoding of the target variable, which is having less than or equal to 50K will be transformed to 0 and greater than or equal to 50K is be transformed to 1. And then there are some categorical predictors such as employee type, education, marital status, occupation, relationship, race, sex and country. They are all have been one hot encoded to make them to numerical variables. The next step, we handle the missing values, which are having the values such as the question mark and NaN. Then all those values have been removed or imputed so that the data is ready for the modeling. Next, we did the feature scaling to standardize the numerical variables so that the logistic regression the data has been ready for the age, capital gain, capital loss, and weekly hours. Then here I'm going to discuss about why we have chosen the logistic regression. So the logistic regression basically is designed algorithm for binary classification. It also predicts the probabilities between 0 to 1 range. And if you see after logistic regression, our feature interpretation will be going to be easy. The coefficients will show which feature is having how much importance, and also the interpretability of the model is very well. So also logistic regression performs very well on the structured tabular data. That being said, for the modeling, we have splitted the data into 70 and 30%. 70% is for the training the model and 30% for the testing the model. After the logistic regression have been chosen, we have been trained the model and then tested the model. So after training and testing the model, if you see the metrics we have achieved in this slide, and same like 84% accuracy after the testing the model. So we achieved the precision of 0.72 and the recall of 0.61. The F1 score is 0.66 and our ratio of ROC to AUC is 0.88. Also, we have did some sample predictions using the test data. If you see the record one, the prediction of the model is greater than 50K salary and the record 2 is less than 50K salary. So according to the accuracy chart, the prediction of the sample records is 84% accurate. And moving on to the unsupervised machine learning algorithm, which is a clustering. So clustering basically we have chosen for k-means clustering to group the data into the clusters to determine how the data belongs to different clusters. So here we have chosen the car evaluation data set, which I am going to discuss in the next slide. So for the k-means clustering car evaluation dataset, there are some predictor variables such as buying price, maintenance cost, number of doors, number of persons, luggage boot size and safety. So the target variable here is the evaluation variable. So here also we did some pre-processing steps before we do the model planning. The pre-processing such as first we determine whether we have any missing values in the data, and then are we having any abnormal values to handle them. So it seems we don't have any missing values on this data, and also we converted 5 more the abnormal values to 5 so that the model doesn't have any problem in processing the data. After that, we did label encoding for all the categorical variables. Also, we did normalize using the standard scalar for the for the variables which are numerical. So after that, we have to do the model planning. So when we are doing the model planning, why we choose the k-means algorithm is it's ideal for unsupervised grouping of similar cars without labeled output. So we also chosen k equal to 4. Why we have chosen the k equal to 4? Because we have 4 evaluation classes, which is unaccount, account, good and very good in the predictor variable, so that we can test the natural discovery. When with respect to training process, so what we did, we have to select the centroids, and we need to assign the records to the centroids, and after we recalculate the centroids, we have to repeat the same process until the model is stable. So after this model has been built, we are planning to evaluate the model by calculating the Silhouette score. The Silhouette score meaning when we got the Silhouette score close to 1, which means our clustering model is very strong. So this is how we are going to build the model, train the model, and then evaluate the model, which I will be discussing in the next slide. Hi, in this slide I'm going to discuss about model comparisons. So I compared two regression models and two classification models, which I will be discussing in the subsequent slides. In this slide, I compared two regression models, linear regression and decision tree regressor algorithm. So the dataset avalon.csv has been used to build the linear regression and decision tree regression algorithms. As usual, the dataset has been pre-processed for finding the null values and also for finding any abnormal values before we start the model development. And then we built the regression algorithm, which is a linear regression. After we built the linear regression and also the decision tree algorithm, we got the mean square error, negative mean square error, and R square. So the slide shows the comparison between mean square error, R square, and also the predictions comparison. So by looking at the parameters which listed in the slide, the linear regression model has a much lower prediction error compared to the decision tree. This means the predictive values from the linear regression are closer to the actual target values, since lower MSE indicates the better performance. Also, the linear regression usually gives us the more stable predictions, the smoother relationships, and also we are able to easily interpret between the coefficients. So we can determine the linear regression model is the strongest model when compared to decision tree. So the decision trees are more sensitive to the small changes of data. If you see the prediction values in between comparatively between linear and decision, the prediction of R1 is the 10.5 years. In linear regression, it was 8.28 years. The same with the second record. For the linear regression, we got 16.84 years. With the decision tree, we got 14.5. So, decision tree is the more sensitive to any changes in the data. With that being said, we conclude linear regression is the strongest when compared to decision tree. The next slide, I am going to discuss the model comparisons between logistic regression and k nearest neighbors. So the logistic regression and k nearest neighbors models are built on the dataset adult salary.csv. The dataset adult salary has been pre-processed for handling all the missing values and the abnormal values. Logistic regression algorithm has been built to predict the salary of the individual whether it is less than 50k or greater than 50,000. The logistic regression has been got the accuracy test and it resulted in 90.13%, where the k nearest neighbors accuracy has been recorded to 87.34%. When it compared to the after we done the k-fold cross validation test to evaluate both the models, logistic regression cross validation accuracy have been achieved to 90.084%, whereas the k nearest neighbor cross validation accuracy has been achieved as 87.65%. By seeing above, we can conclude that logistic regression will perform better since it has higher accuracy. Cross-validation checks how well the model performs across multiple train test splits. So the logistic regression again shows higher average accuracy, meaning it is more reliable and generalizes better across different subsets of data. When it comes to the standard deviation, logistic regression has standard deviation of 0.462, where k nearest neighbors has 0.486. The standard deviation measures the performance stability. Since the logistic regression has slightly lower variation, it is also slightly more stable than k nearest neighbors. Hence, we conclude that logistic regression is slightly more stable than k nearest neighbors. So with this comparison, I can conclude logistic regression performs better than KNN. Now, when it comes to the last part of this project, where I will be discussing the key takeaways from my all understanding. So with this, so far I have been discussed about the machine learning strategy of a ABC form, where we we concluded how the ABC form is going to adopt the machine learning strategies. Next, we did the data pre-processing, where we successfully pre-processed the data of handling null values, how to encode and scale the data before deploy to any ML model. And then we did random forest algorithm for regression and logistic regression for classification and k-means for clustering the cars. And also the last part we compared the model which is performing better. So with this I conclude my final project of 5340 big data. Thank you for listening.